Hello, it's Monday night. It's 9 p.m. on the East Coast, and that means it is time for another Let's Make It. And tonight, I am flying solo. Bob is out spending some time with some family tonight, and I have a pre-recorded segment that we're going to do kind of like last week. It's the second segment of our Eagle discussion, our Eagle walkthrough, and it's going to be a lot of that. So it's just better if he spends some time with some family tonight. But I have been talking about some things that are coming up. And this week I spent some time, and I recorded these segments too for a later time, but some of the things we've been talking about are quadcopters, octocopters, things like that. So this week I'm getting parts in. I still haven't gotten them all, but I've gotten a lot of them in, and I'm starting to assemble things. But I want to kind of show you what we're playing with. So let me I'm going to hold these up in front of the camera, and then I'll go over to the overhead shot. Okay, so this is a frame, an airframe, very light. I think it cost me $13 off on Amazon. It didn't come with any motors or anything, and I don't have the motors for this or the motor controllers. I do have the open source radio or controller for this though. I haven't not mounted that yet. There's a few things I haven't figured out how they mount on here, and they came with no instructions. So I will tell you, everything I'm going to show you came with no instructions, and I actually printed out the thing from Amazon, kind of like cheating on a puzzle, figure out how to put it together, because I could not figure it out. So this is an airframe. Like I said, it was under $15, and there's some landing gear that somehow goes on the side with some springs, and I can't quite figure it out. I've never been really great at puzzles and looking at pictures. So this I kind of put aside since I couldn't figure it out, and worked on some of the other things. But this is one of them. Let me drop that down on the floor. This is another one. This one was like $19, and you'll see I got one motor on it, and I'll explain why I have one motor on it, nothing else. This is a much lighter. This is very light, not as light as the other one that I just had, but it's much lighter than what I'm going to show you. It looks almost exactly like this. This one goes like $19, and they do some neat things with this, because I don't know if you can see on this PC board on the bottom, right here, you see these pads. One pad is positive, one pad is negative, and they got an extra pad on the side, or is up here, and where you plug in you solder on the battery connectors. So the motor wiring is all done through this bottom panel, which is basically a double-sided PC board that is positive on one side, negative on the other side, and you see this little right here where the vias are, a whole bunch of vias going through when they're getting the voltage to the other side of the board for that solder joint. So it makes it a really nice way to wire things. The one I just had doesn't have anything like that, so I had to figure out a way to do all the power management. So you'll notice there's a motor on here, and this comes because the next one I'm going to show you, I've run into some problems as well. Again, this one did not come with any instructions. However, this is very simple because there's only a couple screws that go in a couple places. It makes total sense how it goes together. So I didn't have any problem putting it together and understanding how it went together. The landing gear basically is already on here, although I'm going to add landing gear because I just had to put a camera on this for some reason. The camera would be what it hits, so you can get landing gear that go on here as well. So this is another one. And then we come to the big boy. This is the hexacopter, and you can see it's considerably bigger. Actually, if you put them side by side, you can see how much bigger they really are to each other. This one came with motors, motor controllers, and it came with something else I'm going to show you in a second too that I actually didn't want, but I'm going to end up having another one of these basically because of that. This one I'm having a problem with because I can only get 2 screws in the motor mount. The other 2 screws won't line up. So there's something about how the holes are, and I just got to the point where I got frustrated doing it. It was dark. It was dark in the room I was doing it in, so I just gave up for the night, and I haven't gone back to it. I'd probably do this maybe tomorrow night or Wednesday night and go back to it. But there's something about this one that's different than the others. And I'm going to put it in the camera overhead and show you. You'll see this one has the same kind of PC board where it has power and everything attached to it. But if you look in the center here, you'll see there's a controller built onto this. And you'll see on the side here, see D5, D3, there's D6 is over here, D8, D2, D5. So those are actually pins, the same pins you'd have on the Arduino. So this is basically an Arduino. I can't remember the exact chip it is, but it's basically an Arduino. with a different loader on it, designed just for octocopters, and it's a flight controller. But it's the same chipset we're used to seeing. So we see all this, you know, there's the D3 pin. You look on here, you can see all the other pins that we have on the Mega. This basically is a Mega. And then there's 3 serial ports, so one of them's used for GPS. The problem is, for this particular unit, I wanted to use a NASA controller, which is an off-the-shelf controller, not open source, because it's really designed to do video photography and photography, aerial photography as well, and it has all the smarts built into it to do just that kind of stuff. So when I ordered this, I thought I was getting just a blank piece like this, like the smaller one, but I ended up getting a controller. So I have one coming that this panel is blank, so I can put my NASA controllers on, which means I got an extra controller that I may actually end up putting together just to see how well it works, because this is yet another basically open source controller. If I wanted to, I could actually flash it with the Arduino code and actually write Arduino programs to control this, and that may be what I do in the long term. The problem is, if you crash this and this piece breaks, your controller is broken too. Where if you have a controller that mounts onto it, and you it crashes and breaks this piece, you can just replace this piece. Much less expensive than doing that. So I wasn't expecting to have this controller. And when I first got it, I'm like, what's this? This is not what I was expecting. Had this controller not been on here, I probably would already have the radios and everything mounted on here. Now, these things that are like right here are actually motor controllers. So they take a PWM signal off of any kind of controller, and it controls how fast the motor spins. And depending on how it's plugged in, depends on what direction the blade spins. So in an octocopter, hexacopter, or quadcopter, basically you have half the blade spinning one direction and the other half spinning the opposite direction. So you have, in this case, you have 3 of them going clockwise and 3 of them going counterclockwise, and that's how it keeps it stable and from spinning in a circle. And when you plug the motors, will go a different direction depending on how you plug these in, and then the props are actually designed to spin the opposite direction as well and still give lift. So this is the big one. This is a 6. It's supposed to, I can't remember what the weight is. It's supposed to lift, but this is the one that will actually have. I'll put the camera on, and we'll go through all that stuff in a future episode. But I'm starting to record to put together, and fortunately, I figured it'd be easier to do that because it's going to take me a couple hours to finish the stuff. Like I said, I spent 2 hours on it already, frustrated with a couple of the things. This one I probably spent 45 minutes trying to get the motor mounted properly, and I still isn't mounted properly. That's why I had the motor on the smaller one, and it fits the smaller one. So it's something about this particular piece of equipment. Okay, so that's coming up in future episode. Like I said, this week we're going to do Eagle. Next week I think I'm going to do coverage of a library. So I'm working on a library for one of our hardware controllers so that the controller itself can talk to a video switcher instead of going to our program that does the interpretation for it, that runs on a PC or on Mac. So, but next week I hopefully have that done, and I'll be able to walk through that. I don't know if Bob has anything planned for next week or not. We haven't really talked that in great detail after I got information that he wasn't here tonight. You know, I didn't want to interrupt his night or anything. That's about next week. So we'll see what he has. But at a minimum, I should have my library ready to go as well. So in today's show, I did another pre-recorded Eagle episode that takes the schematic that we did last week and puts it into a physical board and lays it out and walks through what you got to do to output it to send it to a board factory. So that's what we're going to watch tonight. And let me get kind of things ready to do that while I'm talking here. So I'll come back afterwards and we'll talk about some of that. And if there's any questions during the segment play, you can put them in the chat room and we'll answer them when we get back at the end and, you know, kind of get answers to questions. But what I'm going to do is, last week's show notes had the actual PDF of the schematic. This week I'm going to put a couple of different PDFs as well as the actual Eagle file. So if you downloaded the Eagle from like the demo Eagle, I can't remember what the light I think it's called, you should be opening these files up and look at them and play with them and get a good idea of, you know, what all Eagle can do as far as board layouts and schematics and everything. So I'll put that in the show notes. And what they are is our controllers basically have a 2x8 board that controls the buttons. There's going to be one of those in there. There's also going to be one of our breakout boards that we put on the actual Arduinos to connect all the stuff together. I'll put a couple of those out there, different things like that out there as well. So you can kind of get an idea of what all Eagle can do and how we're actually using Eagle now as well. So we'll go ahead and we'll get started, and we'll come back after the segment and we'll see if there's any questions.
This schematic right here. And when we left, we actually went over and we actually saw the actual board layout part a little bit, because I showed you how part can change real easily. However, we didn't really go very far with it. So here we are in the schematic, and again, to get over to there, there's this little button right here, and basically it toggles between the board and the drawing. So we're going to go over here and click on this. So now we switch to the board view. Now by default, it made this work area. This is probably our maximum size work area that we're allowed with this version of Eagle. Maybe I don't know why it's this size. Let me lock my thing so I don't scroll like that again. All right. So here we see all the parts, and you see they're outside of this box area. Here's the thing about Eagle, and you're going to notice this when you try to move a part. So say I pick a part, just trying to maybe to organize it a little bit, and it's going to say you can't do that, because one of the way Eagle controls its licensing is on what it allows you to, what size area allows you to work in. Well, your bottom left corner is this hash right here. So if you pick up something to move it, you have to move it in the area that you're allowed to put it into. So basically what we're going to do is we're going to start moving parts in. So we're going to grab, first we're going to grab the Arduino, because everything has to fit around the Arduino. So you do that by selecting this move tool, same tool as you have in the schematic view. So we click that and we move it over, and we're going to put it right on the hashtag. So now this is really truly going to be our outside of our shield. So let's see, we need to put the chip somewhere, so we're going to move the chip down into here. Now one of the things I want you to also realize is in this side we have a lot more layers. Let's go look at the layers, because I'm going to show you where I'm putting everything. I'm going to leave it where it's at, but I'm going to show you some other options. So if you click this button, it's right here. It brings up this layer display, and we have layer 1, which is at the top. So this is any runs on the top. Layer 16 is any runs on the bottom, and parts on the bottom as well. And then we have the pads, the vias, the little holes to let you cross. Anything that's unrouted, you see our unrouted right here. All this stuff has been unrouted, so that's this color. The dimension is the dimension of the board. The places are the part places. So if I would hide the place, for example, and click apply, you see a lot of this outline of this chip went away because it's the placement outline. Excuse me. So we turn this back on, and we're going to apply it again. And to give you another example, what I'm actually going to do is while I lay it out, I'm going to turn off the unrouteds, because they just become a little bit annoying to get things kind of where you want, and then I'll turn it back on and rearrange the parts so that the runs are a little bit cleaner as well. Alright, so we can scroll down through here and we can see we have names and top and volumes and all this other stuff, so we can turn off all these as we need to. But in our case, we can pretty much leave it all on for right now, and we're going to come back and look at this. But the reason I want to show you these different layers is because I'm going to show you how you can put a chip on a different side of the board. Although I'm not going to leave it there, I do want to show you how it's done, because a lot of my designs I actually do the chips on the back side of the board and put things on the front side, so it just depends on what I'm doing with it. So the way you can determine where you are is you hit the I for info, kind of like we did on the other side, and we click on the actual chip itself, and here you see a little information about the chip. We kind of showed you this before last week, but a little more detail. You name the part, and this part is actually named in the schematic view. You can change it here as well. Its current position, you can angle it, and then if you click the mirror, what will happen is it'll put it on the back side of the board. So you see it turned it around and it turned it blue. Blue says that these runs that are right here on this chip are on the back side, and the reason you can tell that is if you go up to layers, you look at the blue, and this is the bottom layer right there. Now in the case of our shield, I'm going to leave it on top. You can run it on either side. In fact, if you run out of real estate on one side for some things, you can chip over. So we'll see how we do as far as real estate goes, I think we're going to be fine considering we're going to a lot smaller pieces. But I'm going to go ahead and flip it back. I'm going to unclick this and I'm going to uncheck the box. And now we're back on top. You see it turns red. It flips it around so you can read it. So let's scroll out a little bit and we're going to start placing some parts. So we have a bunch of LEDs. Let's just grab the group of LEDs real quick. So we're going to click on the move, and to move a group, we do like in the other one. We click this define a group, and we drag around it just like that. And then when it's highlighted, you right click and you say move group. And we're going to stick our LEDs on this side. And again, this is just general placement. We're going to remove things around when we get it in here. And we have, let's see, our resistor arrays, which are important and probably need to be somewhere close to this. So let's just kind of place them there. And then we have our buttons, and let's see, let's go look at the schematic real quick and see. I have more buttons than okay, I have a reset and a push button, so 2 extra buttons, and it's buttons switches 1 through 8. So let's come back over to the schematic, or to the board, and we're going to look for 1 through 8. 1, 2, 3. What's everyone going to do? I'm just going to move all of the buttons over. For now. And actually, so yeah, I'm having a little bit of issue here because I don't have enough place for all the buttons. So this is our multicolor. We're going to move our reset and our function button to here. And one thing you can kind of remember is we do have space, since we're doing surface mounts, across this area, particularly over here. This one here, sometimes I'll do a cutout, and I might do that on this one, just to make it fit a little bit better. But okay, so we have our resistors, which these can come down here because let's just put them up here. I got space for them here. These are our pull-up resistors for, and then I'm gonna get the stuff over here. So one of the things I'm getting ready to show you, why are these separate, is if I turn on the layer with the unrouted, you can see what attaches to what. So for example, these resistors, let me zoom in here a little bit and you'll see what I'm trying to do, actually go with these parts down here. So I need to flip it around twice. So we could put these and we'll just hold the option key down. There we go. And it goes to here. And then this one. So you can see I can follow these lines and I can kind of see where I'm going. I need to turn this one like this and it will go going down here. And okay, so those go there, and let's see, we have our buttons, which are pretty massive actually, considering that the through-hole ones were much smaller. We're going to go ahead and stick them here. So we have switch 1, and I'm going to turn them. I don't want to move a group. I just want to move. Oh, I got them on top of each other. That'd be why. Alright, so we're going to do switch 1, and we're going to turn it around because it's a little bit shorter this way, and we're going to bring it down to the close to the edge. It's actually not close enough. There we go. I'm going to grab switch 2, and you see I'm going to have to move it a little bit because it's a little close to the chip, but we'll do that after we get everything kind of together here. And switch 4. Switch number 5. Switch number 6. And you see I'm already going on top of this chip, so I'm going to take this chip and kind of move it out of the way, so I can find somewhere else for it when we're done. And we have switch 7. And I think I got these switches a little bit closer together, so I'm going to go ahead and do that. That gives me back quite a bit of space, getting rid of all that extra space in there. And then I have my last switch. We'll turn it around here. And switch 8. Alright, so let's see. Let's kind of bring things back to the center here by just clicking up here. Alright. So what I want to do is, the other thing I want to do is, since we don't need all this extra space, I'm going to bring this down. And we're going to make a box around this, and I will come back later on then and clean it up a little bit, because this is really going to be the outline of our board. I'm just trying to get it close at the moment, and you'll see why in a second. And then we'll come back and we'll clean all this up. I'm actually going to come through and maybe even do some cutout stuff here. So there's that. Alright, let's move this whole thing back. There we go. And so if we get this down. Alright, now when I do this, it'll make things a little bit bigger, a little easier to work with. Alright, so we do have some issues here. So let's look at these chips that are sitting here. This is the chip that goes with these LEDs. Now, one of the things you'll notice is it's on the other side. So if I could find a way to fit this, which I'm going to try, up in this area, and then this one goes with all of these buttons, and you see it's on this side, so it would make more sense that I put it onto this side. Maybe something like this. And so there's questionable ways here doing this. Like I take in, you see how these runs are going. Some of them are going to the switches, and the other part goes to this other side over here. Because, and the thing is, I could probably just do this, which means I might want to turn this chip around. Actually, I think I'm going to do that. So we're going to turn it this way, and we're going to turn it this way. And it may be kind of hard to see in the video, because it's yellow whenever it's selected. Actually, let me do this. Let me. I generally like to do my diagrams for the boards in a dark interface, only because that was what I used. The software I've been using is dark, so I'm used to that. This may help you see it a little bit better. I tried making a white thing to be easier, but I think this could make it a little bit easier. So now you see these chips, and actually because I did that, I'm actually going to move these chips a little farther apart. And this chip may be a better option somewhere else, is what I'm thinking. Alright, this is our lift. So let's see. We're going to bring it over here. Actually goes up there. So those two can sit beside each other, just like that. Alright, let me get rid of a few other things here. Let me get rid of the names layer, just because its value in names, they're messing me up as far as too much stuff on the screen. There we go. Alright, so how can we do that? We have this chip that almost needs to be on that side. Nothing has to be centered, so let me just do this. We're going to move this and this slightly, which will let me move this too. I can take and move all these LEDs down a little bit and give some space to the chip. Now the thing is, this might not be exactly what you're trying to shoot for. If I was being symmetrical, which I generally do try to be, I need to move these buttons then because the buttons are too close to the edge for me to be symmetrical. This would be there. This would be there. So we spread things out a little bit. And actually, I'm going to show you a little trick here that I do to make things symmetrical. Is if you go to Info, you'll see this coordinate is 2.45. Okay, hang on. Let me do this first. We're in inch mode, which inches are very big when you're talking about small electronics like this. So what I generally do is you come up here and you change this, and I just do it in millimeters. And I generally do a 1 and a 0.1 as the Alt. So that allows me to make minor changes by holding down the Alt key. Alright, so that being said, let's go back over here now, and we're going to click on this, and you see it's at 6223 and 1524. So 6223 is where it's at this direction. So that's what I want. So I'm going to remember 6223. I'm going to go to this LED, and I'm going to make it 6223. It already is. So I got it right on the nose the first time. Very rare. Alright, this one is 5588, so this LED would be 5588, and it is. I'll get one 2 for 2 so far. This one's 4953. This LED should be the same, and it's not. So we just put in 4953, and it's going to move it to where it belongs. And we go to the next one. 4318. 4318. So I got that one on too. Now these I haven't touched, so if I don't think they're going to be matching. 3683 and 3683. So that one's lined up. 3048. And we go to the next one. 2413. That one's okay. And this one looks like it's too far, so 1778. Yes, okay, 1778. Alright, so there, we're all lined up. So, what about my chip here? Oops, I don't want to do info, let's go back to move. I need to get some more space around this chip. It needs more space to work. So what do I do here? Well, I have a couple of options. We're going to leave it here and see how bad off we really are. We may be fine where we're at because these runs will be pretty small. So let's see how we got things laid out. Well, let's see. I want this to be reset right here. So let's see. What button is this? It's not reset. See, reset's right here. So I can look at this and say these buttons are swapped. So let's move these buttons around. I want reset to be right here next to the power. And is there any way I can put this up close to the option button? Potentially, yes. We will try that and see what happens. We're going to do a little test run here and see what happens when we do that. And let's see, anything else that I have? Let's just try it and see what happens. I do have some concerns over the resistors do not appear to have both sides connect. Oh yes, they do. They're to each other though. Alright, so let's go back and look at our schematic and make sure that we have our runs connected properly. For these, we have 5 volts, 5 volts. Okay, well they're connected okay. I just don't know why it's not showing there should be a run. Unless I don't have 5 volts attached to the Arduino for some reason, which is always a possibility. It appears to be connected. So let's do this. Just to make sure, we have this thing right here called electrical rules check. Let's go check it. I think we checked it last week, but we didn't. No, we didn't, because obviously there's some problems here. This is what happens when you run the electrical rule check, and it says we have unconnected input on IC1. Reset. Okay, well that's actually OK. We have unconnected input, so we have no address pins. Huh. Well, that's a problem. So we need to put in our address pins. Now in the case of this chip, I'm just going to put it in the ground because I want it to be address 000. So let's go do that real quick. So there's a problem. I guess we did not run an electrical rule check last time. So we're going to put this quickly in just like this. And we're going to... Oops, we need to name it. So we go here to name. And it's ground. And ground. So we did last week. Then we're going to go ahead and label them. Just for good measure, what we're going to do is we are going to put this to 5 volts. You don't want it to float, so it was good catch. But in this case, I think we want to keep it fixed at 5 volts. So we have 5 volts. And let's label this. Now we're going to run our electrical rule check again, ERC. And we have warnings. So let's see. Net. Alright, so we have a couple things here. You'll see this was actually a mistake in how I drew it. See how the green bar goes over top of this pin? That tells me that the pin isn't connected. So I'm just going to be safe, I'm going to redo the pin. So I'm going to connect it. And we're going to name it. And we're going to label it. So let's see, it's label. Let's see if we can get our window back here. It's underneath, there it is. Alright, well this is good. VDD goes to 5 volts, so that's not a problem. We can approve that one. Power via ground goes to VSS, that's fine. My frame has no value, that's perfectly fine. I don't care about if I have values or in the LEDs for that matter. I'm just going to say that's all perfectly fine. And we're not going to even worry about that. So our electrical rule check is fine now. Let's go back over to schematic and see if it looks better to me. 'Cause what's standing out is there's no run to 5 volts from these two. They're connected together but not to 5 volts. But there is 5 volts here. So maybe it's running into here. I just don't see it. Alright. Assuming that we're going to do a real quick run of the board. So here's how that works. You come into this function here called auto router, just like that, and we set up some defaults. So we're going to run the default, and then I'm going to change it and rerun it again because I'm going to rip it up and show you. But basically what it's saying is my routing grid is 1.27 millimeters, which is awful big for these type of runs. And the top I want to try to go up and down as a preferred direction, and the bottom I want to go left to right as a preferred direction. This doesn't always work very well. We're going to try. So there's a few other things down through here. It gets into optimize, and you can give values to different things. I'm not going to go into great detail about this, but basically it's going to go through these optimized routines as well. So I'm going to go ahead and click OK, and it's going to run. And you see it's drawing things. It's so far 31.7% and it finished. Didn't get very far, did it? Look at all these yellow lines that are still here that didn't do anything. So here's what I'm going to do. I'm going to rip them up. So what you do to rip things up is you click rip up, and you click on lines, and they get ripped up just like this. But if you want to do the whole group, again, you can come up here and just click the group, and then we just draw a box around everything, just like so. Right click on one of them and say rip up group, and there we go. This time we're going to run the auto router, and we're going to run it do any direction at once, which just makes a bit of a mess sometimes, but it does get more done. And our routing grid is going to be 0.1 millimeters. Just like that. And let's see how far we get. 85% so far. Alright, we did 100%, but it's now doing optimizations, so it could go backwards with optimizations. Now we're in 3. We're still at 100%. That's a good sign. But 4 is the tough one. Alright, there we go. We are 100% wired up. And we can go turn back on our names and everything to clean things up. But before I do that, I do want to show you something else that if you have the ability to do, I would recommend. And it's called a polygon. And it basically leaves copper on the board. So what we do for a polygon, let me get down here to the polygon. So we do a draw polygon, and we say we want one on the bottom, for example. So we're basically going to draw a box. Where does it go? We're going to draw a box around it like this, and then like this. And you're going to see it's going to turn to a dotted line. That tells you it's a polygon. So I'm done drawing the polygon. But I want to draw a polygon for the bottom, or for the top too. So we do top. And we're going to draw a polygon. Just like this. And now I'm going to rerun the auto router. I'll show you what happens. So you'll notice one of the things that happened was, oh, it didn't show it. Let's run that one more time. Actually, let me do this. Let me rip up everything. That may be part of it. So rip up the group in this range. And now we're going to run auto router again. So you see we're still at 100% optimized 3. It's looking good, looking good. Alright, well, it still did not do the polygons. It took them away. And I don't know what's going on with that. But you would normally see the polygons and everything show up as like solid. So you'd have red. Let's see what layers I'm showing here. So it's top. Let's turn off top one. See things on the bottom. So there's the runs, or they're on the bottom, and then here's the runs that are on the top, making both sides of the board. So you have a two-sided board. All these little holes are where they change sides of the board. They're called vias, and that's all done automatically via the router. But you saw the difference in me setting up the routing options as to what it could do. The default routing options are quite large, and it doesn't always work. But let's do this now. We're going to go ahead and we're going to start adding the pretty stuff to our board. So we're going to turn back on down here. Well, we're going to turn it all on. Let's just do that so we see what all we have. Alright, so here we have all of our names and all this other stuff. I'm actually going to turn off the top and the bottom. Just like that. And you see some of the stuff here. These are what is used if you, these lines, if you get like a template made for surface mounting. So if we're doing surface mounting, it just kind of did that. So I'm going to turn those off as well. You'll see down here that there's glue and cream and all this other stuff that is used. Let me see where the... I think that may get it. Yeah, there we go. Alright, so here we are, and this is what's going to be printed on our board. Well, not necessarily. We're going to... Let's do this. We're going to turn off... Well, now they're going to be printed on our board. So yeah, this is what's going to be printing on our board. So you see we got a little bit of a mess going on here. So what we're going to do is we're going to come in and clean up this mess. And there's a couple ways. You can clean up it any way you want. You can move things around. But to move things around that are attached to like an object like this, you got to smash it first. So we come over here and we smash. And we start smashing these right here. So you see handles show up on the names and everything. Just like that. Now, in our case, I don't need to know the part number, so I'm going to get rid of the part number. And let's see, LEDs are probably okay. I still want to move them around, so let's go ahead and smash them. Just like that. And we'll smash this button. And then we have resistors up here. They have values to them. I'm going to smash those. So now what I want to do is I don't really want these part numbers, so I can get rid of these. You see already it's starting to clean itself up because I'm getting rid of all this extraneous stuff that's not really needed. And let's see this one here. So now what I'm going to do is I'm going to move the words around. So switch 1 is really here. So I'm going to just move things down to where it belongs. Alright, and then the LEDs are, I'm going to do the same thing with this, actually. I'm going to move them out so it looks kind of like the other side. Except for I can't move that one anywhere else. Now here's the thing, silkscreen happens after everything else is done, so you can put it on top of vias or whatever. That won't be covered by the button, so you don't want to do that either. And it won't hurt anything. However, I stick it across a chip because it's going to be copper there. It won't print there, so it would do you no good to put it there. You wouldn't be able to read it. And then I have these resistors out here. Let me get these smashed. I didn't smash these while I had it. And smash that one. Alright, so what I'm going to do is I'm actually going to keep the values and the resistors here. So this goes to this one. This goes to this one. However, I'm going to change the font around considerably. So I just go up to the I, and we're going to make this a lot smaller. Talking, see if it's too small or not. Probably not. So I'm just going to drop it down to 0.8. And let's see, it's the last one for that. Then I can move these back around. So we're going to come in here and R2 at 1.5K, R1 at 1.5K. I'm going to separate them a little bit. Actually, let me just do this. Alright, so yeah, that's looking better already. Same thing up here with these. I'm going to come in here and I already smashed them, so let's just change the values around. And I may just do one of these at 270 because it'll make sense that the rest of them are the same. Actually, that's what I'm going to do. So let me go ahead and get rid of these other two 270s that are here. And 270. Oh, yep. Alright, so and then we're going to make these smaller. We'll go down to the same size, 0.8. Alright, then we'll just move these around. And I'm going to just put them right above them, just like so. And hold the Option key down so I get my 0.1 millimeter there, and I'll move this one to the bottom. And I generally, if I have things that are the same, I just group them together, kind of like that, and just go by that. All right, so there's what we're kind of laid out like. We'll leave switch down, turn sideways like that, I guess. Let's see what else can I do to clean up the look here, kind of. I think that's pretty much it. So next thing we need to do is we need to add in text or like a part number or something like that. So here we're going to call. So we want to make sure our text goes into a different layer. So we'll show you that here in a second. I can't change it while I'm typing it in, but we'll say this is our tally test number 4, and I want to change it to be a silkscreen layer. So we're going to come down here and you see T silk and B silk. So we're going to put it on the top side of the board just like that. And we're just going to call it right here tally test. And I just generally name things by the version numbers by the day that I did it. So this is, what's today, the 23rd, 2014. And then I just add like 001 for version, because if I sometimes make a mistake and come back later on in the day, I'll change the version number around just so I know what it is. I'm going to stick it right here. And it doesn't need to be that big for the version number. So I'm going to shrink down the version number. Oh, something like this probably. Yeah, that looks good. So there we have the name of our board. And if I want to put this on the back side too, I can copy this. So we'll come up here to copy, and we're going to copy tally test, and we're going to drop it, and we're going to copy this and drop it. Then we're just going to change this to be mirrored, so it's going to be on the back side, and we need to change it to the B silk layer. So there we go. So now it's mirrored and on the bottom, and we're going to do this the same thing with the version number. And remember, on the bottom side, we don't hardly have any text. So to consider that, I'm going to show you here what it's going to look like. B silk, and this needs to be mirrored. Let's hide the top layers. So we're going to come in here and hide. Well, place is going to be there. Let's see. Well, okay, we're just going to show you what the bottom side would look like. So we're going to get rid of this. And it takes a little bit of imagination because we can't get rid of everything. Alright, so basically you see there's no words on the bottom. And we're hiding the top layer. So are we hiding the top layer? No, we're not. Now we're hiding the top layer. So this is what the bottom will look like. Well, these parts won't be there though, so you can just ignore what the parts are, but these are the runs you would see. But again, there's no words. So what I'm going to do is I'm going to grab this, and I generally, if I have space on the back like this, will take and make these much bigger. I won't mind not do the version number, but I'm going to put even more information on the website or whatever in this back area as well. And let's see, we're going to make this a lot bigger. Let's see, is it too big? No, that looks good. So now if somebody looks at the back side of the board, they're going to see just the information that you want. You got a little more canvas on the back than you do on the other side where the parts are. So a lot of my boards have parts on both sides, so it's not quite so easy. But remember, they're not going to see the runs really, because they're going to be copper covered and coated in green or black, whatever color you get the board done. And these chips are actually on the front side, so they're not even there. Same way with these LEDs. So this is all going to be just. That's the only word you're going to see on the back is the tally test number 4 and the version number. And then we can come back up here and we can turn all this back on again. It's easy just to click all just like this and to come back on. And there you see our board ready to go. So there we have our board laid out and ready to go. So the next step is to get the board produced is you run what's called a cam job. Now we have cam jobs kind of already set up, so we're going to bring up our cam. And you're not going to be able to see this because it's going to be off the screen, but I'm going to load in our default that we use, and it's just there. So you see, basically we're taking and outputting all these different files. So here's the file name, we're going to put it out, and this is the type of output that it is. It's going to be layer number 20. It's only it's layer 20, 44, 45 that are going to be output into this. It's the section for drills and holes. Then we're going to come over here, and this is our slot drills and holes. So here we have it's layer 20 and layer 46 that are going to be output. And this is the name of the file. And we keep going over here. So here's the solder paste for the bottom. This is what I was showing you where the little gray things are for the solder paste. There it is. It's 20 and it is layer 32. So it's the cream at the bottom. There's a solder paste for the top. So here's the T cream. And then there is solder mask, which is the paint, the green color paint that you put on the boards, both top and bottom, and it just keeps going. So here's the silk screen. Now in our silk screen, we are including the placement and the names, and also B silk right here. And then we have the top silk, and it's the same thing. and we come to the bottom layer. So it's the actual runs themselves, and what we see is we are grabbing we are pads, vias, the bottom, and the dimension, the outer dimension as well is in there, and then we have the top layer. All we do to generate the output to get sent to the PC board shop is just do this, and we're done. We zip those files up and send them to the PC board house, and that's how we get our boards made. Now, the one thing I mentioned before was about dimensions. So what we have done is we've created a square board, because what you see here is the Arduino is indented. We didn't do that. We just did a square. So our shield is going to come looking like this square. So you can adjust the dimensions using any of the tools that you have here to do dimensions. Basically, the dimension layer is, let's just show you. We want to go to dimension, which is just like this, and we can now draw our board cut out as we want. So we're going to do this. You'll see in a second. This is just a little quicker sometimes. Alright, so there's our dimension on the outside. We're going to actually take and we're going to bring that in. Something like that. And you see we have our Arduino shaped board now, so this is what they'll get cut out like. And because we did that, we can actually get rid of the other dimension that was here, because it would confuse the PC board shop if we sent that to them. And one more. Alright, so there we go. We've just done our dimensions. Now the other thing I mentioned earlier was that I sometimes do in this area right here is I will come in and cut it out like this. So you want to bend. We're just going to take and we're going to do this. Thought I had it. There we go. Alright, so I'm going to turn on the option key and do my 0.1 millimeter. And we go just like this. And now we have our cutout, so when we get this board back, the cutout will be cut out just like this right around our USB plug. So we'll leave it in there just like that. Now, this is going to cause a problem. I can see it already. One of the things we haven't done in here is done a design rules check. So let's do this. It's called a DRC, and it's right here, and it's going to, I see some things it's going to complain about. So we just run check. So we have some dimension issues. It says we're too close to the edge here. Which we probably are, and you see there's another one. So you see it's highlighting. Oops, you can't see what I'm seeing. So we have some dimension. You see, you click on this, it highlights where the problems are, and you see if I scroll in down here, it's made it on the screen. Here's your dimension problems that you're having. I should have some clearance issues here somewhere as well. Oh, so here's the other thing. When I did this cutout right here, did you see what I did? I didn't even notice. I didn't see myself do it. I cut off some of the runs. So here's what I'm going to do. I'm going to put this back like it was, for now at least. Let me grab this, move it over. Alright, and I'm going to rerun the design rules check. That area will clean this up for a number of reasons. First of all, here's what I saw right off is I was on top of the resistors when I did that. So let's go ahead and run check again. So this is cleared. But I still have, look, plenty of dimension issues. So let's scroll down here. See, I still have the red down here. And oh, where'd it go? I have the same problem up here, which just means I need to make my board a little bit bigger, which we'll do that in a second here. So all my dimensions seem to be on the side. I fixed the other ones that we're having problems with. But now it says I have overlap issues. So let's see where I have overlap issues. And it's right, I have overlap issues. And I'm not sure how that could be. That's the part that I selected. So we'll have to figure that out. Apparently the part that I was using has some problems. So let's go find something else. And these are all in this same area. So then I have some stop mask issues, which is actually not that big of a deal because I'm not going to use stop mask on this board. So I'm not going to go through and fix those. I will fix the other things here though. Alright, yeah, there's a lot of that. That happens to be around the resistors. I don't know why that is not liking it, but alright, so the first thing we want to do, let's go make our board a little bit bigger. So we're just going to take and we're going to grab the dimension just like this, and we're going to go up two jumps just like that, and we're going to then grab the Arduino itself and move it up one just like that. So our shield's going to be slightly bigger than the Arduino itself because we're fixing that. So that'll fix that issue. We still need to move our... Okay. And let's see. Let's rerun the design rules check and see if it fixes all of our dimensional issues. Alright. No, did not. Okay, so I have one of my buttons a little bit too close to the hole it's going to be drilled. So what I'm going to do is I'm going to move all the buttons. But to do this, I'm going to rip it all up. So we're just going to rip it all up real quick. So we're going to rip up. And since we didn't really do much work to make it work, we're, it's not hurt anything. Alright, so there we ripped it all up. And now we're going to grab all these buttons and move them slightly towards the top. Just ever so slightly. Oops. So what did I do? And you know what I didn't do? I didn't select move group. So I selected move. So we move group. And we're going to go up just a tad. I don't want to go over, I just want to go up. Alright. Hopefully that's enough. So let's do this real quick. We're going to run design rules check again. Oops, I don't want to do that. That's the auto router. Alright, so we are all good with... Nope, we have overlap issues. We got to fix it. Okay. Which I am aware of. Alright, so the other thing that I want to do, especially since we have more board space, is I'm going to move this LED. Maybe that's probably fine. And then I'm going to move the resistors because I want to put that cutout in here, which I took away because I had overlap issues. So we're going to do this. And we're going to move this group. To here. And then I'm going to re-grab this again. And alright, with a split. That's kind of weird. It doesn't like what I'm doing there. Alright. I'm gonna grab this. Having a hard time selecting it. There we go. We selected it. Alright, so yeah, you can see I'm having a little bit of difficulty here. There we go. And I guess I need to split this one more time. So this comes over to here. And we just got to move it up slightly. Alright. You can see how sometimes it's a tad bit difficult. Alright. So there we should be good with our resistors. And let's see, what else do we have to do? We need to replace this. So we're going to do that over here in this part. And where is our LED? Right there. So let's look and see if we have another package, maybe. Alright, so I know where it came from. Let's go look at the replacement options for this. So these are Spark Fun LEDs. And this is... oh, we want common cathode. Well, that's how it looks, which is not right, so... dun, dun, dun. Are these like that? These are, that's the same way. Alright, so those are single LEDs. Let me just see if I can find an RGB. Let's see what we have here. 5mm. Well, that one will work for us. It's not the ideal format for us, but it'll work just fine. Let's just make sure we don't have anything else that's a little bit better for us. Nope, I don't believe so. Tricolor. Nope. So we're going to do this. We're going to go ahead and stick with the Adafruit one, just like this. And we're going to take that and we're going to replace this right here. Alright, well, it doesn't want... they are not exactly the same, so we're going to just insert a new one. Oh, wait. It's backwards. That ain't gonna work for us. That's common anode. I need common cathode. Common anode. Let me just use a different search term. See if I can find something that's a little bit more generic, maybe. Yeah, there's tricolors. We just were Spark Fun. Well, duos, full color. No. This is sometimes the hardest part, is finding the parts, because there's so many that you can pick from in here. Find the one that works for you the best. This is... no. That's not it either. Alright, well, I can't find anything, so for purpose of this demo, we're just going to leave it like it is. It's going to get failures because it's obviously overlapping each other. But now that I've done this, I do have some concerns if this is going to be able to route, because look how close everything is to the edge now. So we're going to go ahead and we're going to run auto route and see what happens. Now, I do want to do one other check of something here. No, I don't want to do that. That's what I thought. Alright, so My blue is not where it belongs. Let me fix that. Not that it seems to matter, but alright, so we're going to do auto route one more time. And you'll notice it did not complete the routes. In fact, it's at 96.3%. So you see what it has problems with is the 3 resistors that I moved over to here. So here's another option I'm going to try. I'm going to rip all this back up again. Rip up and group. Actually, I'm going to do it all. I'm going to do this top area right here. So to know where these actually go, and they're quite far away from this LED, I am going to bring the resistors to the pins, because the resistors are holding back some of the area that's available for routing close to the LED. But if I bring it back here, that area where the LEDs were sitting is now available for routing options. So alright, let's do auto route again and see what happens. It may come back with the exact same results, don't know. No, it went to 100% this time with Optimize 2, so we weren't 100% before. Optimize 3 and 4, 100%. So we did 100% that time. And the other thing you'll notice is we kept our copper this time. We had enough ability to keep copper. So you'll see this red is the front side, the blue is the back side, or am I backwards? Yeah, blue is the back side. So there's no copper on this side because it probably couldn't get to some kind of ground or 5 volts that it needed. This here has both colors, and that just has one color. So we have a lot more copper on our board, which helps with interference, and if chips get hot, helps keep the chips cooler. But to get around our routing problem, I just moved the parts that were passive, aren't visual, doesn't affect user interface or anything like that, to make it so that it had more ability to route things a different direction using a lot thinner lines and taking up this area that's right up here. And then we're good to go. So again, we're going to save this, and then we're just going to go up here and we're going to run our cam job. We're going to open up our recent cam job that we always use, just like that. Process job, they're done. Zip those files up and send them off to our board manufacturer, and our board is done. So now we have just rebuilt our tally test board that was a through-hole board, and we did it in fritzing originally, and we just converted it over to Eagle, and it's just so much cleaner now than what it was before. So cannot speak highly enough about Eagle. That's all I can say for sure. Alright, that is it for this segment.
Okay, there we did. We walked through the schematic from last week, and we turned it into a PC board this week. And we showed you how to export it, and you saw some of the common problems that you run into with routing, especially when I started cutting things out and, for the USB port. You kind of saw there where I had to move the resistors farther away from the actual LED, but closer to the pin where it was being used. It's just one of those things where when you surface mount, you use a little bit more real estate on top of the board, and you just got to move it somewhere else where you can kind of go around it a little bit. So, all right. So while we were, we had some things in the chat room I wanted to cover when we got back about this too. First of all, libraries. If you have a part that you are looking for, go check it out. Look for a library, because there's lots of libraries out there. I know in the chat room I put one for Adafruit. She has a lot of things in her library that are custom, general use type things. It's not one manufacturer; it's a bunch of manufacturers. So let's see. Let's go back here and look at one of the questions. Oh, metric. So yeah, I'm in the United States. Metric isn't used a lot here. And Bob, who's from Jim from Calgary says about using metric. Well, so many things are done in metric, and the things I deal with for making boards are typically in other countries, and they're metric. So I pretty much use metric for everything. The other thing is when you're getting down to small, like 1/10 of a millimeter for routing grids, stuff like that, it just makes more sense to do it in millimeters. Most of the sizing is done for most chips in millimeters. So yeah, I use metric. And I'm getting more and more used to using, especially when it comes to designing boards and things like that. So, and thanks, Jim. He posted in the link in the chat room there again for that library. So there are some challenges in designing PC boards, but I'll tell you what Eagle makes it so simple. The auto routing is great. There's lots of times that it won't get 100%. It'll get to like 99% or 95%. There's a couple of runs you got to do manually. But considering it does the bulk of the work for you, it's still a great tool, and it works awesome. And it seems like it's kind of the standard when distributing CAD files for electronic design type things. So, all right. So it's kind of a long episode again this week. We've been going for, well, about an hour and 10 minutes or so. So we're over our typical, well, we want to hit our hour mark, but it was worth it probably to go through the segment in that detail. But I do also want to remind everybody that you can get our shows on YouTube, and we're also on Daily Motion. You can download our stuff from most of the podcast directories, iTunes or Dogcatcher. We're also on Stitcher. You can get us from there. If you got a Roku app, you can watch us live on the big screen. And also all our old shows are out there as well, so you can do all that. We're on YouTube, like I mentioned before. We had a couple of videos that weren't published tonight when we started. They are published now. I fixed that during the segment playback, so they're out there and running as well. I think, like I said, next week we're going to talk about creating a library. And I don't know if Bob has anything for next week or not, but come back, bring your friends. And also, by the way, I appreciate you spreading the word. Things are growing. That's always a good sign. And it's all because of our viewers and spreading the word around. But we definitely appreciate that. So come back next Monday night at 9 p.m. for the next live show. We'll see everybody next week. For show notes for this show, contacts, and more, go to the TechZen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.